Hello guys, it's me again. Today let's continue with our series of the MOSFET. I mean of the power supply, SMPS power supplies. Okay, before I continue with the power supply, I'm gonna do the same thing again. I'm gonna draw the power supply, and again here we want to supply the RAM with the 1.5 volt. Okay, RAM needs 1.5. RAM needs 1.5 volt. Okay, the 1.5 volt is coming from where? It's generated from the 19 volt. So this is the 19 volt coming from the charger, obvious. So before I continue with my whole series, let me remind you of how the power supplies looks like. Okay, we'll have a 19 volts here connecting to the first MOSFET. We spoke about this the MOSFET on my previous video. I hope you saw how those MOSFETs are switching and why we are saying they're switching, because they are switches. Okay, I did explain the whole thing on my previous video. Please watch that video, you'll understand more. Okay, so these two MOSFETs are connected, and then the output, I mean from them, is going to the coil through a coil. Okay, I repeat again, these two MOSFETs are being controlled by a chip on the fourth gate. On each there would be a chip. This is the RAM chip, there would be a RAM chip. Okay, this is the RAM chip. This is the upper gate, call it UG. Sometimes on the schematic it's not called UG, it's called a higher drive. Okay, and the lower one is called the lower drive, but I'm gonna call it LG, it's lower gate. Okay, but it depends on the schematic that you are using. Some they call it lower drive, some they call it lower gate, and the upper one they call it upper gate, some they call it higher drive. Okay, because the chip is driving these two guys. So actually the chip is telling these two MOSFETs to turn on and off, okay, to generate a spark of 1.5 volts. Meaning when these two chips are on, when this one is on, 19 volts obvious will pass, and then it will reach here and then reach the second MOSFET. When it reaches the second MOSFET, the gate, I mean the chip, will tell this lower gate to enable the chip to close the switch, and then the power will pass and then get connected straight here to ground, which would cause the whole section to be grounded. Okay, after, okay, I repeat again. Okay, let me explain this in a proper way. So here, after these two MOSFETs, you will have roughly something like this: 0, 19, 0, 19, 0, 19, 0, 19, 0, 19, 0, 19, 0, 19, 0, 19. So this whole spark thing will create, will sum to 1.5 volts, but anyway, it's not yet clean, it's not yet rectified. So after a coil, you will have, let me go back to black. After a coil, you will have the electrolytic capacitor, and this is the sign for it. So in this video we are talking about the electrolytic capacitor. Okay, this is the electrolytic capacitor. After the electrolytic capacitor, you will have a titanium capacitor. Oh guys, I can't draw. Trying to draw a titanium capacitor. After a titanium capacitor, you will have ceramic capacitors. Okay, it's always the case. Ceramic capacitors. You will have the ceramic capacitors. Okay, so what they are doing, they are trying to smooth the output of which is 1.5 volts to make it more smooth for the RAM. And then here we have, okay, so from this point we have rough, right? We have rough output, right? After the electrolytic capacitor, now we have a more smoother. Okay, let me just go back and then put that again. After the electrolytic capacitor, from this point, when you check with your oscilloscope, you'll be shocked that you have a more smoother, smooth output. It's no longer rough, but again, it's no longer turning on and off, so bad, so rough, so bad, so bad. No, now it's more steady, it's more nice, it's more smooth. And then this capacitor as well, they will make it more smooth. But already after this guy, the electrolytic capacitor, we have a smoother voltage. Okay, so today in this video I want to make you understand how the electrolytic capacitors work. Okay, today we are talking about the electrolytic capacitor. Okay, let's go online and then let's type okay, wait, start here, electrolytic capacitor. Okay, these are electrolytic capacitors. Okay, see this one at 25 volts, see this one is at 16 volts, see this one it's 100 volts. Okay, in laptops we use this one. Okay, the SMD capacitors is the one that we use in laptops. So it's 35 volts, 50 volts. In most cases in laptops, they are always, they differ. But the one that we I was showing you on the power supply, it's usually 6 volts, 3 volts, but depending where exactly are we using them. But in that case, in my power supply, the one for the RAM, obviously the RAM needs 1.5 volts. Obviously it's possible that they were using 3 volts capacitor. Okay, even 6 volts as well, but more 3 volts is more accurate. Okay, so This drum thing is very important. It's in smoothing the power. Okay, let me explain why it's so important. Let me show you the sign as well, because this is this is for the I mean for your okay, electrolytic capacitor. This is a sign. Okay, capacitor. This is a titanium capacitor. I'll show you. Most cases in laptops they are black. They are more like this. Okay, I'll show you the symbol. This is the electrolytic capacitor. Okay. Anyway, let's go back. Okay, let's talk about the capacitor. So I remember what I was saying. I was saying after the coil, remember the coil, after a coil, the power there is rough. It's rough. The power there is doing this. It's rough. Okay, and then it reaches the thing. The electrolytic capacitor. After the electrolytic capacitor, it becomes smooth. How is this possible? How is this possible? Okay, it's simple. I'll explain everything step by step, but don't mind. Okay, I'm gonna make an example here on how the electrolytic capacitors work, so that you will understand how the capacitors are working, because most of us are confused. Even I, before this thing, it was confusing me big time. And when I check on YouTube, they were saying they are like batteries. Yeah, it's true, they are more like batteries because they can hold power, you know. But again, to me, it didn't make any sense. We understand. So I want to make it more simple for you. Let's say, okay, let me draw the thing why we need them. This is the RAM thing. The RAMs need a clean and stable voltage. Okay, remember the voltage from the power supplies, they are wiggling, they are more up and down, they are not steady. We need something steady. Okay, to do that, okay, we use electrolytic capacitors. How is it possible? Let's say here you have a tap. This is a tap. This is a tap. I think that's how you draw a tap, right? And this is my tap. This is a valve here. This is a tap. This is my pipe. One thing is my pipe. And here you will have water flowing. But now the power supply, remember, they are switching on and off. It's like you are opening and close-ish. It's like you're opening and closing this valve, meaning you will have drops of water, drops, see, drops, 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 going straight to the RAM, because the power supplies, they are on and off. Okay, we don't have a steady or a flowing water, because we are turning the tap on and off, by closing, opening, closing, opening. That's why we have bunch of drops. Okay, so how you gonna make this? How can you make this stable? Maybe for your fruit, let's say this is a fruit, okay, or maybe this, in my case, it was a RAM. So how you gonna make this stable? Okay, it's simple. It's very, very simple, guys. Okay, this is my tap, all right. So if I come here and put a very, 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 very big tank, a very, 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 very big tank. There's my tank. Maybe I'm putting 1,000 liters. Okay, so eventually it will take time, right, to fill, but eventually it will fill. Okay, this is my drops of water. They are dropping here, they'll drop here until they fill this whole place with water, right? Still my tap is turning on and off, giving me drops, but again those drops, they will fill the tank. Okay, once they fill the tank, we're gonna release the tank here. We're gonna release the water from here, from the tank. Say now we are releasing the water from the tank. This is my end point of my tank. I'm releasing water here. So my question here, since the tap is turning on and off, on and off, on and off, closing, opening, closing, and opening, are we gonna get the same result after a tank? Are we gonna have a drops of water here? Obvious, no, we won't, but we will have a stable, steady water going to the RAM, going to your plant, going to your thing. You will have a steady, stable water here, flowing, going straight to your thing that you want to supply. This is your output. Okay, I hope you understand, guys. This is so simple. I have made it so simple for you. So simple, so simple. Now you understand what capacitors are doing. That's why, okay, let me draw it now in terms of the circuit. Okay, this is the RAM. Now I'm drawing the power supply again. This is my 19 volts. I want to feed my RAM with 1.5 volts. This is 1, this is 5, and then I have my V. I want to feed my RAM with 1.5 volts from the 19 volts. Have my tap here. This is my tap. This is my first MOSFET. I'm connecting, and this is my second MOSFET. All connected together. And the second MOSFET is connected to ground, so that the whole thing will be able to turn off. This is why we have the second MOSFET. If we had the first MOSFET, the whole thing won't turn on. We will have 19 volts on the other side, when you close this first MOSFET, you will have 19. But the reason why now we have the second MOSFET, so that the whole thing will turn off. Okay, so here we have a coil. This is how the power supplies are. After a coil, I told you, we have rough output. To make it smooth, what do we need? We need a tank. That's where we are putting. This time I'm gonna draw it as if I'm drawing a tank for real, so that you guys will understand it more simple. This is a tank, and I even said that usually it's 3.3 volts. Now you'll have 3.3 volts. This tank is 3.3 volts capacitor. Capacity of this tank. This is why capacitors are called capacitor, because they reserve something. They reserve power. They hold power. So this tank can hold up to 3.3 volts. Okay, to make it more steady. Now our output will be steady, going straight to the RAM. Take this as a tank, as a 3-liter tank, and here on this side, and here on this side, these are your drops. Turn them on and off. Okay, here, this is your tank, and then on this other side we have what? We have a stable power after the tank. Anyway, thank you so much. I hope you understand how the power supplies are working. But before I go, I'm going to repeat again and draw the power supply for the CPU, because sometimes you might be confused, because I'm always using a RAM. This time, let me use a CPU and explain why the CPU. No, I'll explain it on my next video, but let me just use the CPU. This is the CPU, i7 or i5. This is my CPU. So here I have my 19 volts coming all the way from the charger. Okay, here on my CPU, uses up to 1 volt depending on the program that I use. Okay, but usually it's less than 1 volt, but in this case I'm gonna make it 1 volt. I have 1 volt here. It's my CPU. So how I'm gonna supply the CPU with 1 volt from the 19 volts? Simple again, guys. Okay, let me use different colors. Maybe I'm confusing you. Okay, drawing my MOSFET. This is my first MOSFET. Okay, and this is my second MOSFET. Second MOSFET is connected to ground. Okay, they all connect here. After this, what do you have, guys? By now you should know you have the coil, you have the induct. Here it induces the power, obvious. After the coil, What do we have? We have our tank, the electrolytic capacitor. And you know why we have a tank? We have the electrolytic capacitor connected to ground. After that, you have your output. Before that, you can have the capacitors more and more to hold the power and stable the electricity, stable your output. There we go. And again, I repeat again, I said these two MOSFETs are being controlled by the chip. There would be a chip controlling the switches. I told you the gate are switches. They are more like enable or disable. They are signals telling the MOSFET to allow power to pass or not.